Okay. So we're starting Unit 2. Um, Go ahead and watch the video by yourself there. Unit 2 of Android Basics in Kotlin. And this is the layout unit. So we're going to start with our tip calculator app. All right. Go ahead and watch the video by yourself. And then, so actually we're going to go over their code lab classes and inheritance. Okay, build more complex apps. You'll need better understanding of how classes and inheritance works. So that's so that you can more fully use the Android platform and what it offers. Okay. Before you begin, familiarity with Kotlin Playground for editing Kotlin programs, basic concepts for programming in Kotlin as taught in Unit 1 of this course, in particular the main program, functions, main program functions, with arguments that return values, variables, data types, and operations, as well as if-else statements. Able to define a class in Kotlin, create an object instance from it, and access its properties and methods. I feel like I have some understanding of most of those things at this point. What you'll learn. Create a Kotlin program that uses inheritance to implement a hierarchy of classes, extend a class, override its existing functionality, add new functionality, choose the correct visibility modifier for variables. What you'll build. You'll build a Kotlin program with different types of dwellings that are implemented as a class hierarchy. What you'll need, a computer with internet access and access to the Kotlin playground. Might as well just open that with the link they gave us because we're going to be using it. Next. What is a class hierarchy? It is natural for humans to classify items that have similar properties and behaviors into groups and even form some type of hierarchy among them. For example, you can have a broad category like vegetables, and within that you can have more specific types like legumes. Within legumes, you can have even more specific types like peas, beans, lentils, chickpeas, and soybeans, for example. This can be represented as a hierarchy because legumes contain or inherit all the properties of vegetables. They are plants and edible. Similarly, peas, beans, lentils all have properties of legumes plus their own unique properties. Let's see how you would represent this relationship in programming terms. I think in the last sentence they meant to say that they have all the properties vegetables have plus the properties of legumes. If you make vegetable a class in Kotlin, you can create legum as a child or subclass of the vegetable class. That means that all the properties and methods of vegetable class are inherited by, meaning also available in the legum class. You can represent this in a hierarchy diagram as shown below. You can refer to vegetable as the parent or superclass and legum, superclass of the legum class. So vegetable is the parent or superclass, legum is the child or subclass. You could continue and expand the hierarchy by creating a subclass of legum such as lentil and chickpea. This makes legum both a child or subclass of vegetable as well as a parent or superclass of lentil and chickpea. Vegetable is the root or top level or base class of this hierarchy. So vegetable is the parent or superclass of all the other ones. Legum is the child of vegetable, but the parent of lentil and chickpea. Okay. Terminology summary. Here's a summary of the words used in this code lab and what they mean in contents to Kotlin classes. Class hierarchy. Arrangement of where classes are organized in a hierarchy of parents and children. Hierarchy diagrams are usually drawn with the parents shown above the children. Child or subclasses, any class that is below another class in the hierarchy. Parent or superclass. or base class, any class with one or more child classes. Root or top level class, a class at the top or at the root of the class hierarchy. Inheritance, when a child class includes or inherits all of the properties and methods of its parent class. This allows you to share and reuse code, which makes programs run easier to understand and maintain. Okay. Inheritance in Android classes. While you can write Kotlin code without using classes, and you did in previous code labs, many parts of Android are provided to you in the form of classes, including activities, views, and view groups. Understanding these class hierarchy is therefore fundamental to app development and allows you to take advantage of features provided by the Android framework. For example, there is a view class in Android that represents a rectangular area on the screen and is responsible for drawing and event handling. The TextView class is a subclass of the view class, which means that TextView inherits all of the properties and functionality from the view class, plus adds specific logic for displaying text to the user. Okay. View, which is the parent of TextView, which is the child of view, but the parent of edit text and button. Okay. Taking it a step further, the edit text and button are classes are children of the TextView class. They inherit all the properties and methods of TextView and view classes, plus their own specific logic. For example, edit text adds its own functionality of being able to edit text on the screen. Instead of having to copy and paste all of the logic from the view and the text view classes onto the edit text class, the edit text can just subclass the text view class, which in turn subclasses the view class. Then the code in the edit text class can focus on specifically on what the user interface component different from other views, on what makes this user interface component different from other views. On the top of the documentation page for a Android class on the developer.android.com website, you can see the class hierarchy diagram. If you see Kotlin.any at the top of the hierarchy, it's because Kotlin, all of the classes, have a common superclass, any. All right. To learn more, click here. Kotlin.any, Android.view.view, Android.widget.textButton, Android.widget.button. As you can see, learning to leverage inheritance among classes can make your code easier to write, reuse, read, and test. Create a base class. Class hierarchy of dwellings. In this code lab, you are going to build a Kotlin program that demonstrates how class hierarchies work using dwellings, shelters in which people live, with floor space, stories, and residence as an example. Below is a diagram of the class hierarchy you're going to build. At the root, you have a dwelling that specifies properties and functionality that is true for all dwellings. Similar to a blueprint, you then have classes for square cabin, round hut, and round tower, which is a round hut with multiple floors. Okay. The classes that you will implement is the dwelling, a base class representing a non-specific shelter that holds information that is common to all dwellings, a square cabin made of wood with a square floor area, a round hut that is made of straw with a circular floor area, and the parent of round tower, a round tower made of stone with a circular floor area and multiple stories. Creating an abstract dwelling class. Any class can be the base class of a class hierarchy or a parent of other classes. An abstract class is a class that cannot be instantiated because it's not fully implemented. You can think of it as a sketch. A sketch incorporates ideas and plans for something, but not usually enough information to build it. You use a sketch or an abstract class to create a blueprint class from which you build the actual object instance. A common benefit of creating a superclass is to contain properties and functions that are common to all of its subclasses. If the values and properties and implementations of the functions are not known, make the class abstract. For example, vegetables. Vegetables may have many properties common to all vegetables, but you can't create an instance of a non-specific vegetable because you don't know, for example, its shape or color. So vegetable is an abstract class that leaves it up to the subclass to determine the details about each vegetable. The declaration of an abstract class starts with the abstract keyword. Note you'll come across a number of abstract classes in Android that you'll need to subclass within future code labs of this course. Okay. Dwelling is going to be an abstract class like vegetable. It's going to contain properties and functions that are common to many types of dwellings, but the exact values of the property and detailed implementation of the functions will not be known. Go to the Kotlin playground. I already opened one up. In the editor, delete the print hello world inside main and then add this code below the main function to create an abstract class called dwelling. Okay. So abstract class dwelling. So delete this. Okay. Okay. So dwelling is going to be an abstract class like vegetable. It's going to contain properties and functions that are common to many types of dwellings. We opened up the editor over here, so we're ready to go. We put the abstract class dwelling in there. All right. Add a property for building material. In this dwelling class, you are going to define things that are true for all dwellings, even if they may be different dwellings. All dwellings are made of some type of building material. Inside the dwelling, create a building material variable of type string to represent the building materials. Since the building material won't change, use val to make it an immutable variable or unchangeable variable. Val, building material of type string. Okay. Okay. Run the program and you will get this error. Property must be initialized or be abstract. But I called it abstract. It is. Oh. So do I have to put abstract here? Okay. Building material property does not have a value. In fact, you can't give it a value because a non-specific building isn't made of anything specific. So, the error message indicates you can prefix the declaration of building material with abstract keyword. to indicate that it is not going to be defined here. Add the abstract keyword onto the variable definition. Okay, abstract val building material. That's it. Run your code, and while it does not do anything, it now compiles without errors. Make an instance of dwelling in the main function and run your code. Val dwelling equals dwelling. So we're going to make an object. We're going to make an object of dwelling. Val dwelling equals dwelling. Okay. You'll get an error because you cannot create an instance of an abstract dwelling class. All right. Delete this incorrect code. Your finished code so far is abstract class dwelling, abstract value building material. Add a property for capacity. Add another property of a dwelling that is capacity, that is how many people can live in it. All dwellings have a capacity that doesn't change. However, the capacity cannot be set within the dwelling class or within the dwelling superclass. It should be defined in subclasses for specific types of dwelling. In the dwelling, add an abstract integer val called capacity. Okay. All right. Add a private property for the number of residents. All dwellings have a number of residents who reside in the dwelling, which may be less or equal to the capacity. So define the residence property in the dwelling superclass for all subclasses to inherit and use. You can make residence a parameter that is passed into the constructor of dwelling class. The residence property is a var because the number of residents can change after the instance has been created. Okay, just like in real life. Cool. Abstract class dwelling. Private var residence of type M. Sorry. Okay, private var residence of type int. So we're putting this variable residence right in the constructor of dwelling. So I guess that means we have to pass it in when we create, I don't know, let's see what it says. You can make residence a parameter that is passed into the constructor of dwelling. The residence property is a var because the number of residents can change after the instance has been created. Notice that the residence property is marked with the private keyword. Private is a visibility modifier in Kotlin, meaning that the residence property is only visible and can only be used inside this class. It cannot be accessed from elsewhere in the program. You can mark properties or methods with the private keyword. Otherwise, when no visibility modifier is specified, the property and methods are public by default and accessible from other parts of the program. Since the number of people who live in a dwelling is usually private information compared with information about the building materials or the capacity of the building, this is the reason for this decision. With both the capacity of the dwelling and the number of current residents defined, you can create a function has room to determine whether there is room for another resident for the dwelling. You can define and implement the has room function in the dwelling class because the formula for calculating whether there is room is the same for all dwellings. There is room in a dwelling if the number of residents is less than the capacity, and the function should return true or false based on the comparison. Add the hasRoom function to the dwelling class. Function hasRoom, no parameters of type Boolean, return residents less than capacity. So function hasRoom of type Boolean, return residents less than capacity. Okay. Okay. You can run this code and there should be no errors. It doesn't do anything visible yet. Your completed code should look like this. All right. Abstract class dwelling in the constructor, private var residence of type n, two other variables, building materials of type string, and capacity of type n. We have a function has room for more people, basically. Return residence is less than capacity, true or false. Okay. Next. All right. Create subclasses. Create a square cabin subclass. Below the dwelling class, create a class called square cabin. So we have our dwelling class, and then below that, class square cabin. All right, I got a square cabin class. All right. Next, you need to indicate that square cabin is related to dwelling in your code. You want to indicate that square cabin extends from dwelling or is a subclass to dwelling because square cabin will provide an implementation for the abstract parts of dwelling. Okay. Okay. Indicate the inheritance relationship by adding a colon after the square cabin class name, followed by a call to initialize the parent dwelling. Don't forget to add parentheses after dwelling class name. When extending a superclass, you must pass in the required parameters expected by the superclass dwelling. Requires the number of residents as your input. You could pass in a fixed number of residents like 3. Okay. So dwelling requires the number of residents. So okay. However, you want your program to be more flexible and allow for a variable of residents in square cabin. Okay. It's a fixed number of residents, 3. So square cabin type dwelling. Next, you need to indicate that it's related. Okay. Oh. When extending from a superclass, you must pass the required parameters expected by the superclass. Dwelling requires the number of residents as an input. You could pass in a fixed number of residents, like 3, okay, by putting a 3 in there. However, you want your program to be more flexible and allow for a variable number of residents in the square cabin. Hence, make residents a parameter in square cabin class definition. Do not declare residents as a val because you are reusing a property already declared in a parent dwelling class. Okay, residents of type int. And you're passing in residents. Okay. Okay. All right, so here we're passing in residents from dwelling, and that's what we're saying here. So then we're creating this variable for local variable in the constructor here for square cabin, so we can use this residence within square cabin. I think that's what that means. Note, a lot happens under the hood with these class definitions. In a class header, you see class square cabin residence :int. This is actually shorthand for class square cabin constructor residence : of type int. The constructor is called when you create an object instance from a class. For example, when you call square cabin 4, the constructor of square cabin is called to initialize an object instance. The constructor builds your instance from all of the information in the class, including the passed-in arguments. When a class inherits properties and functions from a parent, the constructor calls the constructor of the parent class to finish the initializing of the object. Hence, when you create an instance using square cabin 4, the constructor for square cabin is executed, and because of the inheritance relationship, the dwelling constructor also gets executed. The dwelling class definition specifies that its constructor requires a residence parameter, so that's why you see residence passed to the dwelling constructor in the square cabin class definition. You learn more about constructors in later code labs. Run your code. This will cause errors. Take a look. Okay, run. Class square cabin is not abstract and does not implement abstract base class member public abstract val building material string defined in dwelling. Okay. When you declare abstract functions and variable, it's like a promise that you will give them values and implementations later. For a variable, it means that any subclass of the abstract class need to give it a value. For a function, it means that any subclass needs to implement the function body. In the dwelling class, you must define an abstract variable building material. Square cabin is a subclass of dwelling, so it must provide a value for building material. Use the override keyword to indicate that this property was defined in a parent class and is about to be overridden in this class. Inside the square cabin class, override the building material property and assign it the value of wood. Do the same for the capacity, saying 6 residents can live in a square cabin. So override val building material equals wood, override val capacity equals 6. Okay. Okay, your finished code should look like this. Abstract class, dwelling, private var, residence, abstract value, building materials of type string, abstract value, capacity of type int, has room, boolean, returns residence less than capacity. So if less than residence is less than capacity, it'll return true. Class square cabin, residence of type int, dwelling, residence. So we passed it in here. It's used in this constructor. This constructor calls this constructor to confirm, check back. Override val, building material wood, override val, capacity equals 6. To test your code, create an instance of square cabin in your program. Insert an empty main function before the dwelling and the square cabin class definitions. Okay. Within the main function, create an instance of square cabin and call square cabin with 6 residents. Add print statements for building material capacity and has room. Okay. Val square cabin equals square cabin. We're going to give it a 6 residents. All right. And then we're going to print out square cabin, capacity, building material, and has room. Okay. Capacity, material, has room. Square cabin, dot capacity. Okay. Notice the has room function was not defined in square cabin class, but it was defined in the dwelling class. Since the square cabin is a subclass to dwelling, has room function was inherited for free. The has room function can now be called on all instances of square cabin as seen in the code. Square cabin.hasRoom. Run your code and it should print the following. Square cabin. Oh, they used a space. Okay. I'll change font. There it goes. Square cabin. Capacity 6. Material wood. Has room. False. Okay. You created a square cabin with 6 residents, which is equal to the capacity, so has room returns false. You could experiment with initializing square cabin with smaller number of residents, and when you run your program again, has room should return true. Use with to simplify your code. In the print line statements, every time you reference a property or function of square cabin, notice how you have to repeat square cabin dot. This becomes repetitive and can be a source of errors when you copy and paste your print statements. When you are working with a specific instance of a class and need to access multiple properties and functions of that instance, you can say, do all of the following operations with this instance object. Using a with statement, start with the keyword with, followed by the instance name in parentheses, followed by the curly braces, which contain the operations you want to perform. With instant name, all operations do with instance name. In the main function, change your print statements to use a with. With square cabin, capacity, building material. Okay. Has room. But all it does is remove the square cabin. Okay. Same. Good. So it works. Run your code to make sure it runs without errors and shows the same output. This is your completed code. Okay. Create a round hut. In the same way that you created a square cabin, add another subclass round hut to dwelling. Override building materials and give it a value of straw. Override capacity and set it to 4. So do the same thing, but call it round hut, straw, and 4. All right. So instead of creating this again, typing everything, we'll just copy it and make another class, paste it. Instead of calling it square cabin, we're going to call it round hut. Building material is going to be straw. And capacity is going to be 4. All right. Yep. Yep. Oh, they had this uppercase. All right. In the main, create an instance of round hut with 3 residents. Val round hut equals 3. Val round hut equals round hut 3. So in main, val round hut equals round hut. We're going to put 3 residents. And then it's probably going to want me to do all of this again, but with round hut. Okay. Play. All right, so we've got our square cabin with 6 residents that we passed in. Or no, it has a capacity of 6, and we passed in 6 residents in the capacity with 6. So has room, it doesn't have room because 6 residents is not less than the capacity of 6, so it returned false. All right, and oh, I still had square cabin in there. Let's change the text to round, rerun it. Okay, in our round hut, we have a capacity of 4. Material is straw. Has room is equal to true because we passed in 3 residents and we had a capacity of 4. So when it runs the has room function, that the residence is less than the capacity. In this case, it's true because we passed in 3 residents and it has room for 4. So 3 is less than 4, so has room is equal to true. All right, so that works just fine. Add the code. All right, run it. You now have a class hierarchy that looks like this, with dwelling as a root of the class, and square cabin and round hut are subclasses of the dwelling. So we did our diagram. Dwelling is the main root of the class. Square cabin is a child of dwelling. Round hut is a child of dwelling. Create a round tower subclass. The final class in this class hierarchy is a round tower. You can think of the round tower as a round hut made of stone with multiple stories. So you can make a round tower subclass of a round hut. Okay. To create round tower class that is a subclass of round hut, add the residence parameter to the constructor of round tower. Okay. Round hut residence. Okay. Create a round tower class that is a subclass of round hut. Okay. Let's do that first. So, class of type array extends round hut. We're passing in residence of type int. Okay. Add the residence parameter to the constructor of round tower. Then pass the parameter to the constructor of round hut superclass. Okay. Override the building material to be stone. Set the capacity to 4. Run the code and you'll get this error. This type is final, so it cannot be inherited from. This error means that round hut cannot be subclassed or inherited from by default in Kotlin. Classes are final and cannot be subclassed. You are only allowed to inherit from an abstract classes or classes that are marked with the open keyword. Hence, you need to mark round hut class with the open keyword to allow it to be inherited from. Okay. Note, you do not need to use the open keyword when defining abstract classes. Example, dwelling class does not need to be marked with the open keyword. It is assumed that you will want to subclass an abstract class in order to implement the abstract properties and functions. To add the open keyword at the start of round hut declaration. Okay, I just did that. In the main, create an instance of round tower and print the information about it. Okay. And we're gonna set the residence to 4 in our round tower declaration or instance object instance. That's when we're creating the object of round tower in main. Round tower equals round tower 4. Now we're going to print out everything about round tower that we printed out. With the other two. Not enough information to infer type variable R. Classifier round tower does not have a companion object and must be initialized here. Alright, sure. Not enough information to infer type variable R. Ah, now it should work. Yep, okay. And we passed in 4. And the capacity is 4, so that works. Alright. Add multiple floors to round tower. Round hut, by implication, is a single-story building. Towers usually have multiple floors. Thinking of capacity, the more the floors a tower has, the more the capacity it should have. You can modify round tower to have multiple floors and adjust its capacity based on the number of floors. So update round tower constructor to take an additional integer parameter, val floors. For the number of floors, put it after residence. Notice that you don't need to pass this to the parent round hut. The constructor floors is defined in here in round tower, and round hut has no floors. Val floors of type int. So create a variable called floors and make it of type int. Okay. And then I think we'll go down here. Override val floors. Set equal to, I don't know, 3. And capacity 4 times floors. Okay, and then we'll add a print statement. Okay. Oh, no value passed for parameter floors. Let's see what it says. I took a guess. All right. Oh, I didn't create the instance. Okay. Oh, wait. Oh, since it has 2 parameters, I gotta pass it in. So let's just, oh, this is where we create the floors. So I don't need to override the floors. I don't need to do this because when I create the object, I'm just going to pass it in. So I'm going to do 3 floors. Maybe not. Let's see what it has to say. I took a guess. Um, Nope. When you have multiple parameters in your class or function definition, it gets too long to comfortably fit on one line. You can break it into multiple lines as shown below, above. Run your code. There is an error when created round tower in the main because you are not supplying the number of floors in the argument. You could add the missing argument. Alternatively, in the class of round tower, you can add a default value for floors as shown below. Then, when no value of floors is passed to the constructor, the default value can be used to create the object instance. In your code, add equals 2 after the declaration of floors to assign the default value to 2. So I guess we can't pass it in like that. Let's see. That's round tower. Oh, sure. All right. Capacity is 8 and only 4, so there's plenty of room. And we can override about capacity times floors. I did that correctly. All right. Modify classes in the hierarchy. Calculate the floor area. In this exercise, you will learn how to declare an abstract function in an abstract class and then implement its functionality in the subclasses. All dwellings have a floor area. However, depending on the shape of the dwelling, it is calculated differently. Define floor area in the dwelling class. Abstract font floor area of type double. Alright, dwelling. Abstract function floor area of type double. Okay. All abstract methods defined in an abstract class must be implemented in any of its subclasses. Before you can run the code, you need to implement floor area in the subclasses. Implementation of floor area for square cabin. Like with building material and capacity, since you are implementing the abstract function that is defined in the parent class, you need to use the override keyword. With the square cabin class, start with the keyword override followed by the actual implementation of the floor area function as shown below. Override function floor area double. Okay. Return the calculated floor area, length times length. Need this because there's nothing inside of it. Cabin. Override function floor area of type double. Turn this thing. Length is not a variable in the class and is different for every instance, so you can add it as a constructor parameter for square cabin class. Change the class definition of square cabin and add a length parameter of type double. Declare the property as a val because the length of the building doesn't change. Dwelling, and therefore all of its subclasses have residence as a constructor argument. Because it's the first argument in dwelling constructor, it's a best practice to also make it the first argument in all subclass constructors and put the arguments in the same order in all of the class definition. Hence, insert the new length parameter after the residence parameter. Okay. Okay. In the main, update the creation of square cabin instance, pass in 50 to the square cabin constructor as length. Inside the width statement for a square cabin, add a print statement for floor area. Your code won't run because you also have to implement floor area in round hut um, and in round tower.
Hey, look what I did! The boss.
Okay. Your code won't run because you also have to implement floor area in round hut. Implement floor area for round hut in the same way you implement floor area for round hut. Round hut is also a direct subclass of dwelling, so you need to override keyword. The floor area of a circular dwelling is pi times radius times radius. Pi is a mathematical value that is defined in a math library. A library is a predefined collection of functions and values defined outside a program that you can use. In order to use a library function or a value, you need to tell the compiler that you're going to use it. You do this by importing the function or the value into your program. To use pi in your program, you need to import kotlin.math.py. Import pi from the Kotlin math library. Put this at the top of the file before main. Import kotlin.math.py. Okay. Implement the floor area function for round hut. Override function floor area of type double. Return pi times radius times radius. All right, and then here I'm going to need to pass in val radius of type double. And then I'm going to need to give it a value when I'm creating the object. So we're going to give the radius a value of 10 in round hut. Okay, 10 point. I think it said 0. Yeah. All right. Add the print statement with for round hut floor area. Okay, now we got to put it in round tower. Implement floor area in round tower. Your code doesn't run yet. It fails with this error. Error no value passed for perimeter radius. In round tower, in order for your program to compile, you don't need to implement floor area as it gets inherited from round hut, but you need to update round tower class definition to also have the same radius argument as its parent round hut. Change the constructor of round tower to also take the radius, put the radius after residence and before floors. Okay. Okay. Update the initialization of round tower in the main. 15.5. Add a print statement that calls floor area. You can now run your code and notice that the calculation for round tower is not correct because it is inherited from round hut and does not take into account the number of floors. In round tower, override the floor area. Okay. Pi times radius times floors. Okay. Yeah, it didn't have us add this override. And we need to account for the number of floors. And Poor Kevin. Oh, I didn't do that. Okay. Floor area. Floor area. Is it that? Yeah. Okay. That's why I did it wrong. With those parameter parentheses in the wrong spot. Floor area. Floor area. Floor area. Okay, cool. Yeah, works. Output should look like this. Yep, it does. For the area values, it would be nicer. It would be a nicer user experience to only show a couple of the decimal places. This is out of the scope of this code lab, but you could print the floor area using this. Print floor area. Okay. %.2f dot format floor area. Hmm. Hmm. Allow a new resident to get a room. Okay. Add the ability for a new resident to get a room with getRoom function that increases the number of residents by 1. Since this logic is the same for all dwellings, you can implement the function in dwelling, and this makes it available to all subclasses and their children. Use an if statement that only adds a resident if there is capacity left. Print a message for the outcome. You can use residence plus plus as shorthand for residence equals residence plus 1 to add one residence variable. Implement the getRoom function in the dwelling. Function getRoom. If capacity is greater than residence, residence plus plus, you got a room. Else, sorry, at capacity, no rooms left. Okay, function getRoom. Implement that in the dwelling. Okay. If resident capacity is greater than residence than residence plus plus print line congrats, you were able to get a room. Okay. All right. Else print line. Sorry, all rooms are full. You cannot stay here. Get function get room capacity is greater than residence. Residence plus plus. Congrats, you're able to get a room. Else print sorry, all rooms are full. All right. In the above code block, you can replace the if condition to use has room function. If has room, the has room function defined as above compares the resident capacity to the number of residents. Okay. All right. This is an example of why inheritance is so powerful. You can call the getRoom function on all of the subclasses of dwelling without additional code in those classes. All right, so in the above code block, you can replace the if condition to use has room function. If has room, function defined above compares the residence. Okay, let's see. Then add some print statements to the with statement block for round hut. Okay. Has room true? Congrats, you're able to room. Has room false? Sorry, all rooms are full. And then it says we can get room. Instead of using this, we can just use has room. See if it runs the same. Okay. Yep. Interesting. All right. See solution for Gisel. Note this is an example of why inheritance is so powerful. You can call the getRoom function on all of the subclasses of dwelling without adding additional code. That's true. Fit a carpet into a round dwelling. Let's say you need to know what length of one side of the carpet to get to the other. What's the length of one side of the carpet to get for your round hut or round tower? Put a function into round hut to make it available to all round dwellings. Okay. Square root. First, import the square root function from Kotlin.math. Import kotlin.math.squareroots. Okay, to that. And then we've got to go down to our Superclass, our round hut. Implement the calculate max carpet length function in round hut class. The formula to calculate the length of the square carpet can be fit in a circle square root 2 times radius. This is explained in the above diagram. All right, function calculate max carpet length double of type double. Return square root 2.0 times radius. Pass in a double value 2.0 to the math function square root 2.0 because the return type of the function is a double, not an integer. The calculate max carpet length method can now be called on round hut and round tower instances. Add print statements to round hut and round tower in the main. Print carpet length. Okay, copy. Print around tower. Print around hut. See the solution. Yeah. And then round tower, even though we didn't add this function to the round tower class, the round tower class extends from the round hut class. And we give this a bigger radius, so that's why it's bigger. So even though this function is in round hut and not round tower, since round tower extends from round hut, and round hut has that function and it's not a private function, we can still reference this calculate max carpet function in round tower and in round hut. But we could not use it in square cabin. We'll get an error. Yeah, unresolved reference because square cabin does not extend the class where the calculate max carpet length function is found. Okay, that makes sense. Congratulations, you have completed the class hierarchy with properties, functions, learning everything you need to create more useful classes. Solution code. This is the complete solution code for the code lab. All right. And they added comments throughout to explain what each thing is doing. Summary. In this code lab, you learned how to create a class hierarchy, that is a tree of classes where children inherit functionality from parent classes, properties and functions are inherited by subclasses, create an abstract class where some functionality is left to be implemented by its subclasses. An abstract class can therefore not be instantiated. Yeah, so basically you don't initialize the abstract class and its properties in that class. You initialize it in subclass. So when you make an abstract class, it's meant to be subclass. And you're meant to override the properties of that abstract class in their subclasses. All right, use the super keyword to reference functions and properties in the parent class. Make a class open so that it can be subclassed. So maybe you already have a class that is a subclass of another class. So if a class is a subclass of another class, it can't be marked as abstract. It has to be marked as open if you wish to subclass it. Make a property private so it can be used inside of a class. Use the with construct to make multiple calls on the same object instance. All right. Import functionality from the Kotlin.math library. Next. All right, learn more. And that is the conclusion of classes and inheritance. Um, First lesson. So pathway 1 of unit 2. All right, done. So calculator. So we just did classes and inheritance. Next we'll be creating XML layouts for Android. All right. So we'll see you in the next video.